Just doing the seconds waiting to make sure we are live. I'm going to assume we now are. So welcome. This is the third of the NCETM's 5 big ideas, and they haven't been done in any particular order. In case you're wondering that if Fluency comes in at number 3 in any top of the pops charts, it just happens to be the order we've done them. But today I'm joined by Faye. Morning, Faye.
Morning.
Morning. Looking forward to this. Always great to have you with it. The session we did a couple of weeks ago, we just bounced back and forth. It was easy. It was fun. But really interesting to hear a lot about the primary side of things because you're, of course, the primary specialist. I'm a secondary specialist for the NCETM. And so Fluency, is it always true that practice makes permanent? Now, if you're watching this and you know nothing about the maths hubs, I will do this every time. Have you signed up yet for the mailing list for your local hub? There are so many opportunities that are being presented by your local hub, all different ones in different areas. But all you do is sign up and find out an email that you don't delete when it goes to your inbox, and you make sure it doesn't go into your junk mail. You take the time to read it, it'll be worth it. So thank you for tuning in. My name is Tom Manners. I'm at Mathematics on Twitter. There I am, popping up on screen again. A PGC tutor for maths, which means I try to keep up to date with research. And actually, by doing my work with the NCETM, I find that I do that quite well. I work as a teaching for mastery specialist. I'm a PD lead and run work groups. And in that respect, Faye and I have a few things in common. Because Faye, there she is on Twitter as Faye Glenn H. Do you mind my asking, by the way, why H?
It was just the name Twitter gave me.
You can change it, you know.
To be fair, it's only been the last few months that I've really kind of got into Twitter, so I didn't know you could change it.
I often thought what the H stood for, but if it had been something private and then suddenly asking you live, that would have been a bit mean, but never mind. You're the lead across your multi-academy trust for maths. You're also teaching for mastery specialist in the primary sector. And again, you are also a PD lead and work group lead. So lots in common, and we both enjoy this. And it was really nice. The last time you came on, you talked about the fact you had maths anxiety at school.
I did very much so. Probably had it even at university. So I remember being in a lecture and I was like, oh, I don't like maths. And I remember the lecturer saying, well, you need to get used to it because you're going to be teaching it for the rest of your life. And I was kind of like, well, yeah, she's right. And it was when I went into teaching that my attitude completely changed towards maths.
That's a really positive thing to share. It really is. So the 5 big ideas. And again, as I said, we are covering fluency today. But they're all interconnected, and as it says on the screen, they're making connections in each of the areas. So what do you understand by fluency? What does it mean to be fluent? Now, producer Adam, good morning.
Good morning. Sorry, it took me way too long to unmute my microphone.
Right, I've got a question for you, fella, and I haven't checked on this before we start.
You haven't prepared me for this at all. So
exactly. So I want that natural response. What's it mean to be fluent if you're speaking a language?
What is it? So I think if like the words would just come naturally to you, so you don't have to think about what you're saying.
What about when playing a musical instrument?
You would be able to just pick up your said musical instrument and be able to play it without kind of having to really think about what you're playing.
And we can see where we're going, therefore. How do they link into working mathematically?
You would be able to apply mathematical strategies without having to really deeply think about what you're doing, having that natural ability, not natural ability, let me scrap that, natural aptitude.
Yeah, I mean, I've heard this word automaticity.
Okay, that's better.
Yeah, but I'm not sure I've said it right. But it's being automatic, isn't it? And efficient. We'll talk about efficiency today, accuracy, flexibility. But these materials, by the way, much of what I'm sharing is on the NCETM website. I'm using some of the initial teacher education slides. And this slide was on there when I've been doing this with my trainees. And I thought that was a really nice way of thinking about it because you don't give attention to it. And you just start speaking the language. And you know, French and German were my favorite subjects at school, actually. Maths haven't been my best one, but I love French and German. And I always thought I was fluent when I wasn't thinking about it, when I was having dreams in French, which was maybe a little bit bizarre, but still, it was true. I wasn't having to think about it. So what do we understand by fluency? It's being automatically almost, and the efficiency. Mark McCourt wrote in his book, we consider someone to be fluent in a technique, procedure, idea, concept, or fact at the point they no longer need to give it attention. When pianists sit down and they know where the C chord is and the F chord and they play them just without thinking, I think this is a really nice quotation. How would you define it, fluency, Faye?
I think before I went into maths and before I obviously explored and did the work with maths hubs, I think a common thing that, from my knowledge of working with primary teachers, you tend to go to fluency is that rapid recall and that quick response.
And I think we'll delve into that because some people then think, did you see the Timetables Rockstars world record yesterday?
Yeah, I did, yes.
The answers under a minute.
Yeah.
But that isn't necessarily the rapid recall. Yeah, well and good, but that's not what we want. We don't just want, can they, fact.
No, and I think in the last 3 or 4 years in the work I've done with teachers in work groups and in my schools that I work in, trying to change that idea of what fluency is, because I think I think lots of time you get bogged down on arithmetic tests, or arithmetic is just fluency, and not actually seeing that it is that application of maths as well, and being able to, just like you just said, automatically do it.
Let's have a look at the key messages. And what I'm going to do is, can you hear, I've left my door open today and the neighbours are now cutting their lawn. So I'm going to open this while reading. Fluency demands more of students than memorisation of a single procedure. And those are those 3 words there we're going to come back to: efficiency, accuracy, and flexibility. And it's not memorising, it's not rote. And I've seen people want to criticise Timetables Rockstars for that, but if it's taught in alongside conceptual understanding and procedural fluency, then that's fine. I mean, it's still impressive. It was over 190, wasn't it?
I think it was 196, wasn't it?
Good Lord, I don't think I'd get 60. Anyway, carrying on. The key messages from the NCETM with regards to fluency: quick and efficient recall of facts, like that kid, and procedures is important in order for students to keep track of sub-problems, think strategically and solve problems. So again, note it doesn't just say facts, it's facts and procedures. And I'm sure that's going to come up a lot of times in this hour. Fluency also demands the flexibility to move between different contexts and representations of maths, to recognize relationships, make connections, and to make appropriate choices from a whole toolkit of methods. Now, some of the key words here keep appearing on the 5 big ideas. So using some of those representations of maths, there it is. And be able to move, making those connections with variation. When we talked about a couple of weeks ago, Faye, you and I, about the connection between the questions. And it's not just do the question, follow the procedure, it's making connections, having an understanding between them, as we talked in the mathematical thinking session last week. And then make appropriate choices. Mathematical thinking, maybe that's about efficiency, which is the best method. And I know I'm going to use an expression that Liz Bridget uses, the lead for the new hub, the Enigma Maths Hub, about a sledgehammer to crack a nut. I know I'm going to be using that today because it's using the appropriate strategy. And fluency, and what we'll hopefully cover in this hour, are strategies in the classroom to actually improve fluency. But it is important we talk about, and I've forgotten, we've got the different representations as well. It'd be nice when pupils can use 100 grid, then use the beads and use the number lines, and being able to actually what's the same, what's different about all these things. We're talking real fluency then, where it's understanding it in different representations and make connections between them all. On these sessions, when we're doing the 5 big ideas, I think it's important we cover research. And so I'm hoping, after I've for some reason shown the, well, I always show the national curriculum, and there it is, the word fluency again, and it will say conceptual understanding alongside it. But let's look at some of the research supporting fluency. Because when it comes to GCSE, absolutely, up to 50% is fluency for the foundation paper. But in the GCSE there, it does say recall, select, and apply mathematical formula. This suggests that fluency is simply remembering facts, but actually it's not that. It's feeling at home with number so as to be able to apply number knowledge and skills effortlessly that come from the Rose Report. So they're able to use them when seeking solutions to challenging problems. So if I go back to this, now, Faye, it's the same in primary, isn't it? So you need to have the fluency so you can go further down in depth.
Yeah, definitely. And I think, like what you were just saying then about GCSEs, 50% of the foundation paper being fluency, I think in primary, we kind of think of, well, in year 6, they have an arithmetic paper. But actually, further in the session, we'll look at how, if they have got that flexibility and that conceptual understanding, that some of those things that they might learn in rote usually can be solved much more simply if they've got the understanding behind it as well.
Awesome. Some more of the research behind it. Now, just to go back again, that fluency is not simply remembering facts, but fluency is often mistaken for rote learning. But there's a nice example here. If a pupil who knows 7 times 8 is 56, they might not know that because that's the one everyone forgets. But if they know 7 times 7 is 49, they use that number sense. to add 7 to get the required number. They know that 7 times 7 means 7 lots of 7, or 8 and 7 lots of 8. Now, with regards to multiplication, what different language do you use as a matter of interest, Faye? Because times doesn't cut it sometimes. I like lots of. I think it links to a visual. But what do you use for multiplication?
We teach the children, so we teach lots of. We teach multiplied by. We've worked really hard in the schools in our trust of kind of using equals the product as well. So trying to make it so that we are really specific with the language. And I know I was talking to colleagues about what is that importance of the language used with multiplication. And we had a big debate of when you're using lots of and the representations, you have to think about which way around it is and different things like that. And I was like, as long as you're talking through it with the children, and I was like, if the children fully understand that you can represent it this way, you can represent it that way, and they can use it, I was like, that shows a real depth of understanding and kind of not to get too hung up on it. But I probably lower down in Key Stage 1, we might use times, but we always kind of refer to multiplied by alongside it. And then we definitely refer to lots of, and bringing the product in as we go up into Key Stage 2.
If I share my screen a second, I'm just going to go to my camera because I'm going to, given anybody who might attend Maths Conf the other week, I did my Speak Like Mathematicians talk, and I have to therefore get the language right. So now you've stumbled across something. This here, 7 times 8, we would say 7 lots of 8 or 7 multiplied by 8.
Yeah.
Now with that, can I use a smaller number because I'm about to draw it? Let's go 3 times 4. Would you just making sure that, would that be 3 lots of 4? You were saying about the right way of representing it?
3, yeah.
So would you therefore say 4 lots of 3? Is that?
This was the exact same debate we were having within it, and I was saying it because obviously it's depending on which way you're. So we've got 3 lots of 4, and if you're circling them horizontally.
Sorry, I didn't mean to talk over you. Sorry, Faye.
Yeah, so that's the conversation, because I think some of the staff within our school were kind of looking at that first representation of, they were like, oh, I'm not sure, but actually I was trying to say, but if you go in the vertical sense, they were like, do we have to put that vertically or horizontally when we're representing 3 lots of 4? And that's the conversation that we were having. And I remember on our specialist training, it took about half an hour of discussion with different things. And in the end, there was kind of this idea of, well, if children understand what it's representing and can articulate that, we never kind of got to an answer of what was the right way.
I think part of that is really trying to get consistency. And that's one thing that I'm particularly keen on. Further research supporting fluency, important that students are able to quickly and efficiently recall facts. It's been suggested that practicing the quick retrieval of basic mathematical should be done as a daily activity. So those daily facts, and we see programs like Numeracy Ninjas, maybe in secondary school, that's just recalling those, making sure they can be recalled quickly, because we talk about limited working memory, of course. And when we said about automaticity, I think I said it right that time earlier on, that would be the idea, just being able to recall it quickly. There it is. The importance of automaticity becomes apparent when it is absent, during lessons when time is wasted with pupils looking at facts they should be able to recall. So there is that danger that's, I think it's worth bouncing back and forth, because we do want pupils to be able to remember this stuff, but just remembering that 20% is a fifth isn't necessarily isn't enough. It's understanding the concept behind it as well. Fluency is key to mastering higher order mathematical skills. And those who respond automatically have that lower mathematical anxiety as well, which is really interesting, actually, because they're not scared of these numbers. They know it's there. It can be developed using reasoning, mathematical thinking, and different representations that we referred to. Both of which will be explored later. That's a mistake. You can tell that's taken from my master's. This is never mind. Procedural fluency, conceptual understanding, and the integration between the two. And we've got to make sure there is that balance between them both. Otherwise, it's just rote with no understanding. And there's this paper of here, which also shows the idea of everything intertwined. I'm not going to go into full detail, but conceptual understanding and, again, procedural fluency are both in there. So then, we, as much like last time, Faye, we just kind of bounced back and forth. Now, I know you want to talk about these 3 lines as well, so I'm going to stop sharing my screen in a few moments. What do we mean by efficiency, accuracy, and flexibility? Because you sent me a slide a couple of days ago, And on the first, I noticed you use those 3 words, and I know I had them prepared as well. So I wanted to make sure I handed over to you at this stage. A really nice word summing up fluency: efficiency, accuracy, and flexibility. So yeah, can you talk us through?
I'll just share my screen. 1 second.
3 really good words. I mean, accuracy. What's different about fluency, I suppose? Accuracy would be with that kid who got 196 in the minute. Yep, so it's just wrote, and it is, of course, an element of fluency. It doesn't mean we're going to ignore it. We want the kids to get it right. It's like, oh, I understand everything, but I think 2 times 3 is 90. That's not the point. But it's an element of fluency. It's not the entirety of fluency.
No, and I think that's what, and I know in a lot of people that I've worked with within schools, in my own trust, that I think is what they think about when they think about fluency, is that quick, right? They've got it quick, they know it, they don't need to think about it. And actually, so I've got these from the Enrich, I've got the link there, so I've just kind of taken bits from what Enrich has said about it. But I suppose kind of that efficiency is being summed up of not getting lost in too many steps, having the strategies to work easily and quickly to carry out the thing, but not getting bogged down with that and seeing the most efficient way to work out the problem. I don't know if you've got anything to add to that, Tom, at all with the efficiency.
We'll do some examples later on, because I think for practicing strategies for the classroom, I think efficiency and flexibility are the ones that I've got strategies to share today. Accuracy, there isn't a strategy because it's getting it right, isn't it? But I really want to look at numeracy ninjas a little bit, because I think that's really good practice. Like timetables, rock stars, there are just recall and this accuracy here. The knowledge of those number facts, which, as it said in one of those research articles before, it's more obvious when it's absent, and it takes the time to look it up, and it creates that anxiety. So of course it's an element of it. It's just not the entirety.
And I think as well, building on that accuracy, it's looking at as well that it is that correctness, that being correct. But I think it's also as well linked to that checking on things as well, and checking that you're accurate. So I talk to children, we talk about use the inverse and things to check your answers are correct. And if they're not accurate with that, then they might be wrong within that as well. So I think part of that accuracy within fluency is being able to check that you've got it right as well, and being able to do that quickly too.
And then mind, isn't it? It's the mathematical habit of mind, estimation and checking. I know Polio's research in problem solving, the 4th part is go back and check. And it's that typical thing that pupils type something into a calculator and the answer is 900. What do you mean the answer is 900? I asked you 3 times 12. Oh, the calculator said so. It's like, well, you haven't given any thought whatsoever. I don't know how you got 900 from that, because I'm not that. But they haven't given it any thought. They've just performed what they consider to be a procedure, and therefore they haven't gone back. They've not got the mathematical. I like what you're saying about accuracy there. They should be going back to check, having a rough idea. Estimations of key habits of mind and maths.
And I think flexibility was the one that kind of opened my eyes the most when I was starting to delve into what fluency was further. And actually, that it links back to all those ideas that you were saying at the beginning, Tom, of that spotting the patterns, spotting the relationships between the different things, that if you know one thing, you know another thing. And I think we practice that as practitioners in primary, and we'll look at things of like using known facts to solve things, but we don't necessarily refer that to being fluent. We refer that to something differently as well. So that one was quite interesting for me. And do you want me to do that reading thing that I did that was on my slides with
let's do it.
Yeah. So I always try to, because I know I've got lots of teachers that I work with that do have maths anxiety, and so I try to look at things in a different way to try and help them. And that was just there about that memorization. So I got this from the website that I'll put at the bottom there. But kind of thinking about how we assess fluency in schools, and I would largely say in my own trust we assess fluency through arithmetic papers that we do with the children. With that, and I suppose compare that to reading. So if you think about how you assess children in reading, we might do it in test conditions, but obviously we have guided reading sessions where we listen and observe what they're reading, and we listen to, are they fluent readers, can they comprehend things, then we ask them questions about it. And I kind of says, well, think about if you only could assess reading on a timed test, which is what we tend to do with children in maths. We tend to assess their arithmetic ability or their fluency on doing an arithmetic test or doing a times table test, and we don't necessarily look at it anywhere else. And then this is just a bit of an activity that I did. So if you could only assess your reading on just a timed test, like we do our fluency maths almost, would you be confident in what you came out with? And then an activity that I've done is this memorization versus understanding. So I'm just going to put something up on the screen, and you've got 5 seconds to memorize a list of 12 words.
Okay, go, bring it on. It's that girl curly chair with a brown go.
And then obviously what I got staff to do is write down as many that you can remember. And I obviously was like, no, talking to the staff and asked them to write down as many of those words that they could remember. And on average, we got between probably about 4 and 6 words that people would come up with. I don't know if you've done it there, Tom, and how many you got.
Yes, sat with a brown curly chair. Lemon.
And then we show the same thing again. So now you've got 5 seconds to remember the words again.
Girl with curly red hair sat in a little brown chair.
Yeah, so it kind of shows that memorizing, which, as we've just said, is a part of mathematics, and we want children to have that recall of facts and things. But understanding
the word "the" is only on the right one.
Oh, is it? Sorry, I've missed that one out.
There's "at" on the left. And "the."
I'm sorry.
You've just taken all the credibility out of this presentation.
But yeah, so it's kind of trying to get that message that if we teach fluency with understanding, then children are going to be accurate, they're going to be efficient, and they're going to have flexibility, rather than just focusing on this idea of, oh, we've got an arithmetic test to do, or we've got a times table test, and only seeing that as the fluency that children do.
I'm sorry, Fer, I don't know if you're about. Are you wearing a bracelet? You're banging on your table.
Oh, sorry, yeah.
I'm hearing it. It took me ages to work out what it is. In case I'm sorry. Thank you.
No, it's fine. So I think that's kind of it. I know when I did this with staff the first time, they're like, we've never really thought about it that way. With that, and again, that just goes into the things we've been talking about in a bit more, in a simpler terminology with that. So I just think it's that rapid recall, that instant recall of facts is one element of fluency, and it's not the be all and end all with it. It's obviously we want children to develop it, but we can develop. They'll get to that if we're teaching them for that understanding, for that flexibility, for that efficiency as well on there. So. And then just kind of, I found this quite interesting. This is from when we had our mastery specialist training. We'd be given these questions and actually looking and thinking about, well, which of them do you heavily rely on factual recall? Can you spot, where do you spot relationships? And I know from a practitioner in the classroom, a lot of children would all go to an automatic written method for this, because we don't necessarily look at, well, where's that efficiency? What's the efficient way? Is there another way of solving this? And that obviously 32 take away 27. I know I've got year sixes that would still do column method for that, but not actually just see that there's a difference there of 5 and look at it that way. And the 25 times 10, they'd sit and do column method to work it out, but actually realising you could do 25 times 10 and then take off one lot of 25 within that. So I think that's something that we miss opportunities for, really, to teach.
I want to make sure we spend a bit more time looking at that if we can, actually, just to cause I think that's one of the key messages that people could be taking away, that if you had somebody in the classroom and there's different methods being used, that there's the discussion. So if whiteboard work and whatnot, everyone doing their own whiteboards, and you walk around the room and think, okay, I've seen that people use that strategy, I've seen that people use that strategy. You grab them, you hold them up and say, well, what do you think about this one? Does it work? Great. Was it accurate? Brilliant. It's fluent. We're happy with that. Is this one? Yeah, it's fluent. It's accurate. But compare them. What's the same? What's different? But then which is the most efficient?
Yeah.
And as you come to that, I think that then gives me an opportunity to share a couple of examples from me, if I may. Because I think in fact, I know some of these were taken from SATs. Elizabeth Bridget, as I say, from the Maths Hub, did this for me: a sledgehammer to crack a nut. So 1,000 taking away 7, and there it is, the standard method. Again, 16 take away 9. Is it really necessary? If you know that they're so close to each other, well, we would hope there'd be steps up. 7s into 56, having to go through the whole procedure. I like this one. Wow. But then there's SATs questions like these. Yeah, real SATs questions.
Can I just interrupt you there, Tom? Because I was in year 6 a couple of years ago, and we kind of were really focusing on developing fluency and making sure children had all these flexibility and this ability to go between questions. And I remember with my it was my whole year 6 class, and we were looking at dividing by 1 and timesing by 0. And the children were going, why are we doing this for, miss? What are we doing this for? We don't need to do this. We know when you times by 0, the answer's 0. And I says, well, and they says, we know when you divide by 1, the answer's the same. I says, well, why is it? And they went, because it is. And I went, well, why is it? And they went, because it isn't. They were going, we don't need, and we kind of looked through and we showed why when you multiply by 0, it's always 0, and why when you divide by 1. And then still at the end, when we was looking at some questions, some of those children who might be perceived to be higher attaining children or working more at a faster pace, like rapid graspers, because they went straight to the procedure still and they hadn't really listened, they still got the answers wrong to them. And I just think don't assume that your 6 children or your year 5 children know these things, or they know why these things happen.
So there's an example of when you use different language for multiplication. So lots of, times by 0 sounds like a procedure. Multiplied by 0 sounds like a procedure. Lots of 0, you can represent really quickly. We're like, I'll give you 5 lots of 0 sweets. There's 1 lot. Have another lot of 0.
Yeah.
You like some more? There you go. Have a couple more. How many have you got?
That's literally what I did to them.
It just shows the importance of using the different language, the right context, and in that respect, with regards to multiplying by 0, actually lots of is surely effective. Other SATs questions. So again, that looks like a question you want to use column subtraction, but that's so close to 12,000. Just add 1 more on, and you've got the difference, and that would be really powerful there. There's that question, the kind of thing we talked about earlier on. If you know 7 times 7 is 49, you should know what 7 times 8. Now, look at the connection. If I know 5,542 divided by 17 is, I also know 326 times 17 is 5,542. And suddenly, times by 18 is just another lot of 326. And that's the greater depth. There's a language often used certainly more in primary. But that's efficiency, that's knowledge of facts, that's fluency. It's also great reasoning. Don't think things have to be pigeonholed in maths, and I think this does happen sometimes where if people want to have conversations. I'm going to cover this up a second. Have conversations about. I'm thinking of 2 things at the same time, so I've got to show this now. Showing different methods, but yeah, things are allowed to be fluency and reasoning. Adam Ball, the work that you set for our department, because I was in school yesterday and the emotions are coming back to teaching after a long break, fantastic. But can you remember this from the paper that you
I didn't actually teach the year 10s, but...
Oh, you were doing 12s, weren't you? This is an AQA question, and I know Steve Lomax shared this in his presentation, Do It, Twist It, Solve It, because someone tweeted about this question, and they said... I think Charlie was the name of the pupil, saying, hold on, you're telling me to do something, I think equal, let's say 3. And without expanding the brackets, solve it.
Right, yeah.
And it's like, hold on a second, I've only ever learned expanding the brackets.
Yeah.
And suddenly be able to have the idea of dividing by 9 to both sides was completely, they had no idea of it. And you were saying that a few moments ago, Faye, that actually knowing those different methods. Because if you're told in the question, I mean, I don't like referring just to exams, but it's just narrow, isn't it? If they only knew one method, then what about if they get that method slightly wrong? If they can't remember that method fully as well, they're not fluent enough in their maths to be able to go and use a different method.
So,
yeah.
Tom,
if I just share, sorry, Adam.
Just linking to that, somebody on the chat has just asked, how would you encourage students to choose the most appropriate method, or would you encourage students to choose an appropriate method?
Faye, do you want to go first and I'll answer that as well?
I think, first of all, you've got to provide the opportunities for that. And I think you've got to, like you were saying, getting the different methods that children might use and showing the different ways and then talking about which is the most efficient is there. And I think we don't provide enough opportunity for that in primary sometimes, because it's all about getting through to the next thing. And actually you can, as you were just saying, we talk about greater depth. in primary schools a lot. And actually, that is depth. If we're exploring a concept or how to do something in 4 or 5 ways, and the children themselves then are experiencing that as well with you, rather than just pigeonholing, this is the way we're doing this today. And then they're more likely to come and see if you're talking through how this way was done, talking through why this way works as well. They're more likely to come to seeing what is the most efficient, because they're looking at the different ways, whereas if they only know that one way, they only know what they know.
I saw that, I refer back to these same things quite often, but Gary Lamb shared something on Twitter where if they just can't remember that one algorithm, then they're stuck. And Jane Jones said it with Craig Barton's podcast. There are so many algorithms to learn. If you don't understand them, if there's just too many, there's got to be an understanding of maths. It's the two peoples, the one who thinks that maths is full of rules, who hates it, the people who thinks that maths is no rules whatsoever. It's just understanding and interconnected and loves the subject because of it. I'm going to share, because I've got a couple of maybe strategies. So as that question now come in, I think it might be worth going to it. How can we develop fluency in the classroom? I think we're referring to them a little bit already, but let's make sure we're really clear with them. 2 strategies: opportunities to select appropriate strategies, and then comparing strategies using worked examples. So let's have a look at these. These division questions here. Now, for all of these, pupils could use short division. They won't use the bus stop.
I'm glad you've said that, Tom.
Yeah, okay, moving on. In fact, is it at this stage I should quickly do this? I know I did this at my slam talk on Maths Comp the other day, but I'm going to repeat it because the effect size, it's really interesting. I know Adam, I showed him this for the first time, and I've done it a few times now, but the more I do it, the more people are likely to see it, the better. So there is the short division model. Might be the right word, I don't know. But all we're asking, that link to multiplication is suddenly really very clear. And so 7 times what is 56? And that's what we're asking, is how many 7s going to 56? It's the same as saying 7 times what is 56? And if they're much better at their timetables and they immediately say 8, well, you know what? We're making that explicit link between the two topics. But there it is. Short division is just, it is an extension, if you like, but multiplication, is it not?
Yeah.
Worth sharing that, because the number of times I share that particular kind of example, people get really excited by it. So what would be the appropriate strategies here? Now, we could use short division for all of these. For the first one, probably the right one, maybe. I would imagine. The second one, you've got a couple of options. You could divide by 2 again. If you think that's better for you, short division works, but you know there's the flexibility of changing it. Dividing by 10 for 810, I think we know that the zeros disappear. It doesn't, I know there's a trick involved, but of course that's just part of the procedure when we're later on doing it. Now this last one, it could be written as a fraction, and then maybe dividing both numerator and denominator by 2 and then by 3. Could be short division. It's choosing the appropriate strategies for each of these. But even having those questions all next to each other is an opportunity, isn't it, to build fluency, because it's not just do the same thing 4 times. It might be use different methods 4 times.
And I think that's really key as well. I think a big thing that we do with children in our schools as well is we ask them to do things in different ways. So we'll mark so many questions on whether we highlight a question or different things, and we'll ask them that you need to show this in a different way, or you need to show the representation, or whatever it is. And I think if you kind of just say that, or if you can show it different ways, show me a different way. But actually, if you make it really specific that I'm expecting this question for you to look at an alternative way to do it, and I'm looking for this question, what's an alternative way to do it? And they actually have to, because again, children, especially in primary, but if you've looked at short division, that's the thing they will go to. But if you're saying, like, so if you just highlight a question to and say, I want you to think of a different way that you could solve this one, they've got to think about it differently all of a sudden.
And I think we've got to be very consistent in our lessons to make sure that we are saying regularly, is there another way? Can you show me another way? And this is, as the question came in, it's the right thing to be asking. They're going to be more efficient if they are able to use other ways of doing it. I'm thinking of quadratics all of a sudden, solving quadratics in secondary school, because you've got the formula, you've got factorizing potentially, you've got completing the square, you've got drawing a graph, and you can even say to pupils, well, which one were you going to use and why? Choosing your strategy and explain why. So it's not something you're going to do in one lesson, and much like virtually all the stuff we do in this, nothing works on the first lesson. It's got to be a consistent message of which is the appropriate method here and why, and regularly saying, don't just use the same algorithm 4 times. Decide which one you think is best. Have a go at it. If you were wrong, who cares? You found out why you were wrong. Go back and do another one. It's not, the answer is only the beginning. It doesn't matter. Developing those fluency in using different methods is really important. And so again, here, selecting an appropriate strategy. Divide by 3 times by 2 for the first one, maybe. Or if you know a third, you take it away. And in fact, that's probably better for number 2, isn't it? Because timing by 7 is never popular. But if you happen to know an eighth of 24, then you could take it away from 24. Divide by 12 times by 6 seems a little pointless for the third one, because recognizing that we've got a half, so just divide by 2. But then adding a 12th. So I think the same is being shown there, Faye, unless there's anything that any other methods that we'd be talking about.
No, that's what I would have done as well. But I just think it's kind of worth pointing out that number 3, although to us it's really obvious that it's a half, that's not to children. And and it's like you were saying, that whole, it's got to be part of your day-to-day lessons. And I think this idea with episodic teaching and having all children working together in primary, which I know is something with mastery that we're trying to achieve, but it does allow for those opportunities to explore different ways of looking at things as well, because you're kind of letting them have a look at something, let them go, bring them back, explore it, let them go off again, explore it. And there's kind of those opportunities built in then to look at short division, for example, in different ways, and how can we divide numbers in different ways as well. So
2 things. I love the fact you did mastery in inverted commas, because I'm a big fan of that. But also, next week, I think with Helen, we're looking at coherence, and those small steps are easier to take. And one of the things that people get worried about when they're approaching this way of teaching is, well, there's not time. Well, that's the thing about short, small steps in depth. It's more likely to stick because we've made the pupils think. But also that's the point of breaking down the work into those small steps. And then you do create that time. And if they're made to think, they don't have to struggle as hard to remember it later on. If it wasn't an algorithm that they didn't actually give any attention to, which we talked about in week 1 with variation. And we're seeing more and more how they find big ideas are just aligned together, which is takes a while to get. And that and again, just becoming a specialist doesn't mean you know it. It's forever a journey for us as well. So you could be using it as the word best, but it's not necessarily the nicest thing. I like the word efficient. But what do we mean by best strategy is a word that we'd be using in the classroom, maybe, or most efficient strategies. Different strategies might be better for different students in different contexts at different times. And it said, can you give why in this presentation? But again, you look at for quadratics. Well, if it can factorize, I'd probably factorize it. I don't want to go through the whole rigmarole of using the equation. I might, if it's got a coefficient of higher than 1 x squared, then actually I'm not going to complete the square. These are topics you fully remember, of course, Faye. Completing the square, yeah.
Quiver at some of them, Tom. Quiver at them.
There's that nervous laughter that we want to move on from. Comparing work examples. Again, 3 pupils have here got the same idea. This example taken from the Making Every Maths Lesson Count book, which I champion all the time. But whose strategy is better and why? And during the conversation now, is there the kind of taking away of this little rectangle up here? I think there is. Is that over there? I'm not sure that method's on it, because there's loads of methods. You break it up here, break it up here, break it into 3 different parts. Which is better and why? There isn't necessarily a right answer. And that might be, do you find this way that sometimes the teachers will think there has to be a better strategy, but actually it's just the comparison that's more important than deciding which is better?
Yeah, and I think it goes back to what was on the previous slide about the children as well and the different students. So I remember having a student in year 6 again, and we were looking at long division. And obviously there's the procedures and things involved of showing long division. and they just couldn't get it at all. And then we showed the same dividing, it was like a 4-digit number by a 2-digit number, and they used short division for it, and they could do it, and they got it straight away. And obviously what's happening to that number is the same, but that idea of that, yes, that's the way that the national curriculum or whatever is saying that we need to do, but if a child works more efficiently in that method than this way of doing it, then you've got to have that flexibility to allow them to do that as well.
I've got a couple more examples that I think are worth sharing. This one here. Now, you have to use the left-hand method. God knows why. But it's important to have that. I mean, certainly when maths goes forward, and I know that Mark McCourt talks about teaching everything right the first time, but forward-thinking maths, because actually having that grid method is really important. It links to area, it links to all sorts of different things, expanding brackets and all the different ways we can use the grid method. But of course, you can use long multiplication for those, and actually showing that key sentence that's been highlighted there. What's the same? What's different? Really, really important sentence. Easily one of my favorites. Again, taken from the Emma McRae's book. In fact, I think the next example is as well when I think about it. Yes, it is. Now look at the questions that you can. So comparing worked examples, I'm obviously mentioned this a few times, but look at the question below. Give an example of an equation where it would be better to use Mullen's strategy. Now that's suddenly just being a little bit more clever, because just comparing Mullen and Mamie, and do you know anyone called Mullen and Mamie, by the way? Now, I know that Emma will do, because I know that all the names she's used in here, because she told me this, that people she knew. Now, in this instance, if it was solve 3 lots of x plus 1 equals 14, then Mamie's method wouldn't be as pleasant, because you'd start getting fractions earlier on in your working. So there's a really lovely question of, well, give me a suggestion of the best type of question for this method, and give me a suggestion of when it's best to use this kind of method. So even just that, not just looking at the question that you're talking about in the lesson, i.e. this one here, but do it the other way. Using this method, give me a good question. Using this method, give me a good question. And again, same here, whose strategy is better and why. It's an uncomfortable word for me, a little bit better, I'm not going to lie, going back to efficiency. But then again, looking at this is a much better method. Look how much less work, but it's a calculator method. So really nice to be able to have comparing worked examples. Oh, Helen tweeted this last night, so I forgot to put it into the presentation this morning. Why do some children use a written procedure? That's exactly what we're doing today. Yeah, so because Helen was running some of the CPD for the Central Maths Fund. Awesome.
I think just whilst you're there, Tom, I've got this one that I always remember it, because it was when we went to the first induction training for my specialist before I was obviously doing the specialist training, the mastery specialist training. And this question came up, and it was Debbie Morgan that posted this question. I was with a colleague at the time, and how would you solve these questions? And the colleague I was with had solved them one way, and I'd solved them a different way to them. And they were going to, there's only one way to do it. And obviously the way that they've looked at, which is the way we may have taught children in the past, or we may still teach children, is to, okay, so we've got something add 17 equals 15 add 24. So we might teach children to, right, well, we add these two together, and then we get the answer, and then we've got to take the 17 off whatever the answer is here to find the missing one. And that's the way my colleague had worked it out. And for the first time, and I was so proud of myself, it was the first time I'd actually started working more efficiently. And I was like, no, you've just got to redistribute the numbers. And they were like, what? And they couldn't work it out. And kind of just trying to bring in that representations can really help sometimes. So then I obviously didn't have deans there. I just drew this out on a piece of paper for them. So here we've got the 15 and the 24. And then I says, we've got something add 17. I says, so how can we make that 15 into 17?
Wow, that's quick like that,
and
isn't it?
And he was like, well, I was like, you can just take away those two. And then all of a sudden you've got 22, and there's no, and they were like, I didn't even think about that at all. And then with the second one, with the 90, they were like, oh my God, I see it now. You can just move. So again, you've got, rather than working it out, you can just move that 9 across, and you're taking away the 50 instead. And I think sometimes that when we're talking about it, because with this question, if I just go back through, with that question there, when I was just trying to explain, well, you can just make, you're just taking 2 off the 24 to make that 17, and they couldn't see it at all. And then as soon as I drew it out for them, they were like, oh my, a bit like, oh my God, that's so simple. I'd never think to do that way. So that's kind of, again, where you're just saying the 5 big ideas linking in.
Yeah.
The representations, and children, especially young children, don't just assume just because you're telling them that works. They won't believe you until they've actually physically got those things and they've moved them themselves, and they have those light bulb moments where they're like, oh, it does work, I don't have to. And we kind of call it, in primary school, I always call it, we call it working smarter, not harder, with the children. So we kind of always say, what's the smarter way to work rather than the harder way to work with them.
That's nice.
So yeah, so just thought I'd share that as well.
No, that's brilliant. And again, I was on the tip of my tongue ready to say it's a reminder about the 5 big ideas. We're on session 3, and we're forever referring backwards and now referring forwards to the session, because we're doing representation in a couple of weeks, aren't we?
Yeah.
And so that's going to be great. I keep changing my mind, which is my favorite, but representation, I mean, look how easily that just became accessible and the structure was there. Go on.
Sorry, I think as well, just because I've got it here as well, if it just shares 1 second. Sorry, it's just
with your jingle jangles still on as well.
Sorry, I'll just lift my wrist.
That's fine.
With a key stage 1 as well. So we talk about that children always get confused with this missing box. Do I add this? Do I subtract this? And again, well, you represent that there, and well, here's the 28. So here's the 50, and we're touching into that, obviously, representation again. But for children, again, that we talk about, I have lots of conversations of, well, my lower attained children can't be fluent with things. Well, they can. It's just they look at things in a slightly different way as well within it. So, and I think sometimes providing opportunities, I got this activity from Enrich.
Can we just go back a second, Faith?
Yeah, of course.
Just take that previous slide. My immediate thing there was a number line. And I just wanted to talk about multiple representations, and that will help develop fluency as well. The fact that we can see it on a number line, so some pupils will want to use that tool. Some will want to go and grab those Dean blocks. The Dean blocks aren't available, but also it's the vision in your mind, isn't it? But yeah. I immediately thought of, well, what's the difference? There's 28 on a number line. There's 98 on a number line.
What's that difference between?
Yeah. And I think this is part of what we're doing today about that flexibility, because we mentioned earlier on efficiency, accuracy, and flexibility. The flexibility between which is the representation I want to use, and then seeing what's the same, what's different.
Yeah.
Sorry, go on to that.
And then I was just going to say, so again, I've done this with some of my year 6 pupils. It was an activity I got off Enrich. And we were looking at fluency, and some of it was quite interesting to see. Some of the children looked at it and were just like, I haven't got a clue. I didn't even know where to start. And obviously, we was working and kind of looking at, well, you can only use the numbers 0 to 12 to do it. So if you look, obviously, this one here where you've got a square times square times square, and sometimes children in primary, it might not be the same in secondary, but so children in primary, when you start looking at things that the numbers aren't there and it's different shapes, they get completely thrown by it. So we kind of looked at, well, if you've got a cube number here and you're multiplying that same number by the same number and it equals an amount, there's only a certain amount of digits you can use to do that. And obviously, if you've got 0, you're going to get a product of 0. If you use 1, you're going to get a product of 1. If you use 3, you'll get 12. If you go beyond 3, you're going to get a bigger product than 12. Yeah. So kind of starting there. And then obviously here, you could also start here and seeing that, well, they're multiplying different things by the triangle, but it's always equals in the triangle. And it was just really interesting to see. And it kind of goes back to that flexibility. Those children that were flexible enough in their thinking to think about, well, what do we know about multiplication with things, and how can we manipulate what we know in different ways? Whereas for some children, because there was no numbers here at all, it just completely threw them as well. So obviously it's one of the Enrich problem solving activities, but I found it, when we was trying to look at fluency, I found it quite interesting to see who was flexible in their thinking as well.
Another example of exposing pupils to different types of questions in different ways, because if you've only given them the same 10 questions that all look the same, suddenly that different representation, you're doing the first, that's algebra. You're making those first steps of algebra, which is needed. And again, it's that forward-thinking math that Mark McCourt thinks about and talks about. It's making sure not just that they can perform on that day in year 8 or year 3 or whatever it might be. We want them to perform up to year 11 and beyond. Let's not put a cap on it and say year 11 because GCSE is not the majority of people done with maths. We want people to think mathematically, preferably forever. That would be nice. It's not maths is finished, hooray, and throw things in the air. That's not what we try and encourage, at least anyway. I think certainly what I wanted to make sure we came back to, and I'm going to just share my screen one more time, is make sure those kind of key takeaways. And I've got a few of them here, and hopefully that's to start sharing on screen in just a few moments. So these are the 3 words I really want to make sure we come back to before the end of the hour. Efficiency, accuracy, and flexibility. And you showed a screen earlier on. Efficiency using an appropriate strategy or algorithm with speed, preferably. So I'm a little torn as to whether those lines should be there, those words should be there or not. But with speed, again, we'll be back to being efficient. Accuracy. Yes, it is important that we get the solutions correct. But of course, you do get marks for working. And flexibility, adapting strategy and transferring across context. And what did we, so let's just think about what methods we used in the classroom to summarize them again, Faye. What did we use today to try and encourage each of those 3? And by the way, that paper and all the, I don't think I've been doing this enough. I do all the references, then I forget to upload them. So I'll put them all on my website from all the videos I've done, and we'll get around to that. Efficiency, using an appropriate strategy. So what we've said, Faye, is maybe whiteboards, which one was more efficient and why?
Yeah.
So having those conversations in the classroom.
Yeah, and exploring the different ways that children have come up with things. Yeah.
For accuracy, yes, we have those little tests, if you like, but as you pointed out with the reading, if we just did a timed reading thing, we're not actually testing their skill. I thought it was a nice way of putting it, but of course they've got to be getting it right. Flexibility, adapting strategy and transferring across context. So seeing it as you showed in a different way.
Yeah.
Was important. Which is the best method and why? The AQA question I showed about the expanding brackets. Well, actually make encouraging which is the best. In fact, efficiency and flexibility, I think, and again, this happens when you're presenting and you're trying to think of lots of things at once. I often would maybe confuse the 2 a little bit. So your slide, which I think I've actually got on screen. So yes, I have it on my screen. I'm going to go back to your screen because I think it shared it quite nicely. There you go. Requires the knowledge of more than one approach. Because of that example, one example I've shown, but knowing which is the appropriate strategy, as it says there, but knowledge of more one approach. When should I use one ahead of the other? And that was the question, wasn't it? I showed the Mullen and Mamie thing. The idea, in fact, I'll just make sure that's really clear because we know that we can only handle so much. There we go. Dual coding and all that. Give an example where one would be better than the other. So not just focus on the example you're doing, but now we know these 2 strategies. Give me a question you know you'd use that one for. Give me a question you know you'd use that one for. And now we're giving away strategies to help people, teachers, encourage the fluency of the pupils. I'm hoping we are anyway. I think we're getting towards the end, Faye. There's certain things that you'd like to point out at all, because I've got a couple of things
And the only thing that I was really going to share was, and it's just again, sorry, 1 second. It was just linked to kind of looking at it from a key stage 1 point of view, that I just wanted to speak about were these facts, these number facts. I don't know if you've seen them before, Tom.
Let's see it.
So these number facts. So this is something that in our teacher research groups we look at a lot of the time, and these are known facts. And so these are facts that we say children in year 1 and 2 should, by the end of year 2, should know. So the year 2 ones are that block in the middle here, and they shouldn't come out of year 1 and 2 with the strategies and things, but they should just know these facts. But I think what's important is we kind of talk about, well, there's a progression to teaching these, and that you have to look at the strategies involved with them and the efficiency involved with them, so that by the end of year 2, they can remember them. And if you just kind of, I know I've worked with schools in the past where they're kind of like, well, we test them every so many weeks on them. And I'm like, well, what are you doing to encourage them to remember and learn them? And they're like, well, they just have to practice them. And sometimes it goes beyond that. Like we were saying earlier, it's not about memorizing that we've got 3 add 4 equals 7. And I thought this was quite a nice way when I first saw this, because it's color coded to, well, here we're talking about adding 0, we're talking about adding 1. There's that progression in, well, what strategies do we need to teach the children so that they do become accurate in answering these as well. So I just thought I'd share that.
Fascinated by that slide, and we're running out of time. It's a real shame. But this, of course, reminds us about coherence, the small steps. Another link to the 5 big ideas. And teaching them, as you've got on your next slide, that the small steps is key to making sure we actually have the opportunity to intertwine the two, procedural fluency and conceptual understanding, as one of the diagrams I showed earlier on with the scales as well. It's not just procedural, it's that conceptual understanding and being able to do the, and be able to actually be able to explain what is going on. I've really enjoyed today. Some great things. Let's get some of the key takeaways though. And a reminder of the messages from the NCETM. And again, please go onto the NCETM. But, do you know something I was going to do, wasn't I? Right, the NCETM website, here we are. Some of the essence of maths teaching for mastery, procedural fluency and conceptual understanding are developed in tandem. It's a vital part of the practice. We use intelligent practice that we did a couple of weeks ago, Faye. But also this next slide, this next page here, if you go onto the NCETM and it talks about supporting research and evidence. And so scrolling down on that, learning facts. Is it true that some people can't do maths? So Daniel Willingham, if you haven't read much of his work, it's certainly worth it. This paper offers evidence from cognitive science of cognitive overload. Again, it's learning facts can be recalled automatically. It frees up the working memory and avoids that cognitive overload, so we can actually work on what we're trying to achieve in today's lesson. The Cambridge Maths Espresso, if you're more interested in research, these are put out quite regularly. Why is working memory important for maths? And so some of the research behind it is on the NCETM website. It is free to join. That's the point. Everything we're trying to do is government funded because we're trying to get all this stuff out there and share it with people. But these are the key messages from the NCETM when it comes to fluency. Demands more of students than memorization. Again, that might be the accuracy part of it, as we see here. But we've talked about efficiency and the flexibility between them. Quick and efficient recall of facts and procedures is important to keep track of sub-problems, and we've just seen the reason why again, maybe because of, certainly because of working memory. But we talked about that flexibility to move between different contexts and those different representations of math. Which would be the better method and why? Well, how did it look like on a number line? How did it look like in Dean's blocks? How did it look like I was using number beads, for example? And there's a really important word we haven't used once today, toolkit. We're giving the pupils the toolkit to choose the appropriate method, strategy, and approach. And actually, when you build mathematicians, you build their toolkit. It's not just, here's how you do it. Well, choose which tool you need. Okay, you don't get a hammer to try and screw in a screw. You choose which one out of the toolkit you require. Those key takeaways: demands more of learners than memorization of a single procedure. Again, if you get that single procedure wrong, you're stuffed. Demand the flexibility to move between those different representations and make those appropriate choices. Now, Faye and I have both over and over today talked about the links between all those five big ideas. And that comes to nicely recommend that. Next week, Helen's back. We're looking at coherence. Those small steps are easier to take. And all the links of the previous sessions we've done and all the future videos will also be on my website. I should mention my ResourceFULL series. If people don't use MathSpot, then Jonathan did a brilliant, and he's actually agreed to do a second one already for me. A brilliant hour where we went through how you can use the manipulatives, but also for secondary colleagues, some of the tasks he's created for the classroom. Honestly, it was just a phenomenal hour. Resourceaholic, Joe Morgan, I've spoken with, Open Middle, that I know would be a lot, certainly for primary and secondary as well. The More Same Less tasks, and Jean Knapp joined us for that as well. So many resources that pupils could be using with regard to developing their mathematical thinking. One of the 5 big ideas. But Faye, I really enjoyed, because today, being in the middle of the 5, we started to link everything and hoping that then helps people to think, well, why is this important? And it might be people are using different, we're not here as NCETM representatives. We both happen to be doing that course. And I know we're talking about the 5 big ideas, but neither of us are paid to talk about it today. It's just making sense, isn't it?
Yeah, definitely. And I think it's important that you see it. But as you said at the beginning, Tom, as well, they do interlink so much, and they're not just taught separately. Each math lesson will have all 5 of them in most of the time.
And I think that's a really good way of ending, Faye. I'm not going to beat that. So I'm going to call it a day there. Thank you very much for listening and watching today. And Faye, I will see you in 2 weeks for representation.
You will do indeed.